Example number 3. At the New Age Information Corporation, the age of all new employees hired during the last 5 years are normally distributed. Within this curve, 95.4% of the ages centered around the mean are 24.6 and 37.4. Find the mean age and the standard deviation of the data. So this question is a little bit different now. I've been given I've been given the percentage of my age range. So let's start off by drawing a sketch, like always, and then label. And when we label, we should find out the information. So I have my bell curve like we've done for the last 2 problems. Now this one I don't know what x bar is, so I'm just going to write x bar. I have 1 standard deviation plus 1 minus 2 plus 2. So 95.4% of the ages. When we first described the approximation of the percentages, I knew that 34.1% existed between my 1 standard deviation below. 34.1 exists between 1 standard deviation above, and then 13.6 and 13.6. These are all percentages. And if I added up these percentages, I would find that 95% of my data is within 2 standard deviations of my mean. 95.4% within 2 standard deviations. So this is key information, because if I know that I'm within 2 standard deviations of my mean, I could just find out how much, I could just find out the percentage when I could find the range. So that'd be 37.4 plus 24.6 divided by 2. This would give me the average between my 2 standard deviations. So I find that my mean is 31 years old. So that's only part of the question. The next part of the question was I need to find out the standard deviation. So I have x bar equal to 31 years old. I have that x bar is 31 years old. So between x bar, 31 years old, and my 2 standard deviations away, 37.4, I can find the average of 1 standard deviation. So 1 standard deviation would be equal to 37.4 minus 31 divided by 2. When I do this on my calculator, I get that 1 standard deviation is equal to 3.2 years. My apologies for that. So with example number 4, we're going to have the last type of question we're going to be seeing with normal distributions. Take a moment and record this example in your notebooks. We have this topic of percentiles. So when we've been having our normal distribution curve, we've been looking at the percentages between deviations. But now we have this new topic of percentiles. While calculating a percentile, we're looking at the probability to the left of my value. So when I have x bar, which is my mean, right in the middle, we know that the percentage to my left represents 50%. So to the left, we said that this was 50% under my curve. So we call this the 50th percentile. It would be the same for my first deviation. Below my first deviation, I would add up all the percentages, and I would find that my first 1 deviation to the left would be the 15th.9. percentile. So let's look at the question. The lengths of 100 pipes have a normal distribution with a mean of 102.4 inches and a standard deviation of 0.2 inches. If one of the pipes measures exactly 102.1 inches, its length is example 1, 2, 3, or 4. So let's first follow our procedures. We need to sketch and label. I'm just going to scroll down so we have room. So when I draw my sketch, I have my normal curve, I have my mean. We know that x bar was equal to 102.4. And I'm given that the standard deviation is 0.2, so I can go above and below. 102.2, 2.6, within one standard deviation. And then -2, +2 above, I get 102.0 and 102.8. So the question asks for 102.1. Where would that be? It would actually be right between two standard deviations below and one standard deviation below. So on your reference sheets, we see that we have 1.5 standard deviations below, and this would be equal to 102.1. So when we look at the percentile, we're looking at the percentages to the left of -1.5. So I'm looking at the percentages to the left of -1.5. Oh wait, so we're looking to the left of 1.5 standard deviations to the left of our mean. When I add up these percentages, I find that I get 6.7. So what this means, that when I add up the percentages that exist right in here, I get 6.7%, which means that I'm in the 6.7th percentile. So we usually don't hear percentiles described in such an odd way. Normally say you're in the 90th percentile, the 80th percentile. But this is the exact percentage where the standard deviation is. So looking back up at our question, we see that the answer is obviously below the 16th percentile. So take a moment and copy down the notes. I wish you all well and have a great day.